Hi everyone, and welcome to the second Women on Stage conference. Thank you for being here. I'm super excited to be here today again, and I'm thrilled to have all of you joining us once again. My name is Moran Weber, and I'm the CEO and founder of Women on Stage. And for those of you who weren't with us yesterday, Women on Stage is a global community platform to showcase, book, and train women professional tech speakers for any event, conference, meetup, or webinar. The platform was launched in May 2020 and achieved overnight viral success, already making it one of the largest databases in the world for women professional tech speakers. Our mission statement is to amplify women's voices everywhere and to create a world where women make at least 50% of tech speakers. Because we believe that if you can see it, you can be it. Apart from the platform, we also launched the second course of the Women on Stage Academy, which is a full-blown course to train the next generation of technical women on stages. And today is the second day of our ending conference, where each of our 30 graduates will present their talks after they've been building them and polishing their presentations throughout the course for the past 3 months, after getting personal feedback from world-class speakers and mentors. Our speakers are working in senior positions at some of the best-known tech companies in the world. And on top of that, we also have 3 keynote speakers opening each day. Our speakers are going to present highly technical professional sessions covering data, machine learning, NLP, backend, cloud and big data, frontend, React, mobile native development, security, software engineering methodologies, quality assurance, architecture, and many, many more. And before we start, I'd like to thank all of the people and the companies who made this course and this conference possible. Thanks to all of our awesome sponsors who actively choose to promote diversity as part of their mission. We truly couldn't have done this without you. Be sure to check our job board with lots of wonderful opportunities. Thanks to Event Handler Productions for producing our conference and to the team organizing the event. Special thanks to all of the course instructors, which are world-class speakers and true legends. And last but not least, to our talented, brilliant, and dedicated mentors who accompanied our students throughout the course. All right, so one last thing before we start. You're welcome to ask questions on our YouTube channel. The sessions are pre-recorded, so the speakers are going to be available during their talks to answer all of your questions live. We love to hear your thoughts. Ready? Here we go.
Hi, I'm Yael Ben David, and I want to talk to you today about getting out of your own way so that you can take the stage. Time for you to speak up. Let me tell you just 1 minute some background on me and why I'm here today. I started by doing a first degree in journalism at New York University, and then I moved from New York to Israel in 2007. So I'm going to talk to you today about a concept called imposter syndrome, when you feel like you don't belong. And boy, did I not belong. I came to Israel, I didn't speak any Hebrew, I didn't have any friends or family, I didn't even have really anything in the way of money, and I showed up completely foreign. Immediately, anywhere I found myself, I did not belong, I was an imposter. And then, as if that wasn't bad enough, after a journalism degree, I went to Hebrew University for a master's and a PhD in neurobiology. I certainly had no experience in any related field, And every class I sat in, and everyone else who sat there with me knew more than me about whatever was going on. I was a complete imposter. In the end of the day, I decided to combine these two sets of experiences and skill sets to become a UX writer for complex products. And today I write for Fundbox, which is a financial tech, a fintech product here in Tel Aviv. It actually extends credit to small businesses in the US. So there are a lot of very complex concepts to explain. I have no history, no experience in the financial industry. I had to learn everything from the beginning, and so also there I was an imposter from the beginning. But the main reason I'm here in front of you today is because I do not suffer from imposter syndrome. So this is me in September 2017, literally my first day on the job as a UX writer, and I had never heard the word UX in my life before. Fast forward to today, it's been less than 4 years, and I've spoken at more than 7 conferences, 4 meetups, 3 universities as of yesterday, and on and on and on. Here you see in October 2018 was my first time speaking to any kind of an audience. It was within the company I was working at the time. And already by January 2020, this was my first time speaking to what I could call a proper audience. More than 150 UX and UX adjacent professionals who could really call me out if I said things that made no sense, live, again here in Tel Aviv. And how do you get from what happened in September 2017, never heard of the name of my own field, to less than 4 years later, all of these engagements? And the answer is by not having imposter syndrome. It's okay to have an imposter moment, right? Valerie Young was quoted in Time magazine for saying that you can have an imposter moment, but not an imposter life. And that's really what I want to talk about today. Not moving imposter syndrome aside. It's here to stay. It's not going anywhere, but that's okay. Having a moment is okay. Right before I get on the stage, right before we turned on the camera, feeling like this might be beyond me, that's okay, as long as I do it anyway and I don't live my life as an imposter and let that hold me back from doing things I really am capable of doing. So the first step in sort of powering through and overcoming and even leveraging imposter syndrome to do what we do better is to name it. So Google tells you that the definition of imposter syndrome is doubting your abilities and feeling like a fraud. It'll cause you to question whether you are deserving of accolades, right? So when someone claps, I don't really deserve it. They're just being nice. Okay, so that's the feeling I think a lot of people are probably nodding their heads. You can resonate with, that resonates with you. That's what we're really discussing today. It's self-talk that you don't belong. You're telling yourself that you don't belong. And it's self-talk that you don't offer value, that you might as well not participate, don't get on that stage, don't take that job, because you don't actually have anything to contribute. You don't deserve to be there. That's a bunch of malarkey. And especially because I'm speaking in a forum of women, I want to remind everyone what imposter syndrome is not. It is not humility. It is not modesty. It is not, I think we're taught from a young age, not to be braggarts, not to look arrogant. And there's a difference between being a humble, modest person, which of course is something indeed to be complimented, and feeling like an imposter. And I really want to drive home that imposter syndrome, if we're already defining it, is a thing that is not fair. Women suffer more than men, and I don't mean that men don't feel imposter syndrome. Research has shown that 70% of all people feel imposter syndrome. The difference is that men feel, oh no, I'm a fraud, oh well, and just continue on doing whatever it is they do. Women get in their own way by saying, oh no, I'm a fraud, and taking it to the next level and saying, and someone's going to find out. I better not put myself out there because I'll get discovered. And it's also very connected to the glass ceiling, to the difference in pay. We receive less money because we don't ask for the same money. We tell ourselves, well, I don't really deserve it. Maybe if I get paid a little less, it's okay if I'm not as good. Minorities suffer disproportionately. If you think about it, that ability to say, I'm not really good enough, but who cares? That is the definition of privilege. And a lot of very talented people don't have that. And imposter syndrome prevents the community from benefiting from your contribution. It's not just about you. If you let it get in the way of speaking and sharing and teaching and mentoring, then those people, your potential mentees, and all of the rest of the community, they suffer from your imposter syndrome because they don't get to hear what you have to share. So if we're going to sum that up in a slide, imposter syndrome is a lie, self-talk that's just not true. It's stunting your growth, and it's stunting everyone else's growth around you. That is no good. So let's first talk about, since this starts in your head, right? Imposter syndrome is something you're telling yourself. So how can we flip that narrative in our head? So I'm going to give you a countdown here. 5 techniques that I think will help you fight a concept in your head with your own mind. We're going to go from maybe something a little less novel to things that I feel are more unique, more valuable. We'll work our way up. So number 5, fake it till you make it. I'm sure you've heard this before, and here's why it should work. First of all, everyone else is doing it too, right? If you're faking it, they're faking it, everyone thinks everyone else is faking it, and if you're all doing the same thing, well then that's no longer faking it, right? That's just doing the thing. And if you're doing it while faking it, you're still doing it. So that first day on the job when I had never heard of UX writing, I was still UX writing. I was like faking that I know how to do UX writing by doing UX writing, okay? So faking it counts. Number 4, external validation. So it isn't my favorite, but it is useful. So I want to share it with you today. The idea of looking around and seeing that outside of you, there is proof that you do belong. So first of all, you're here, right? So if I thought I shouldn't get this job, well, the HR manager thought you should get this job. They hired you, right? So the fact that you're on this stage is validation from the conference producers that you belong here. And the fact that you have this job is validation from the hiring manager and the hiring department that you belong here. So don't be arrogant. Don't say, I know better than them that I don't belong here. It's their job to decide whether you belong here. It's very backwards, right, to say, I'm not good enough. I know more than they do, that I'm not good enough, right? Trust them. Number 3, imposter syndrome is not you. Now, this is kind of a heavy concept. It's going to take a minute to wrap our minds around, but it draws on the school of mindfulness, where something is much easier to fight or power through or leverage if it's external to you. So imagine in your head, you're here and your imposter syndrome is there. It is not who you are. It does not define you. It is outside of you, and it's up to you to make it a moment and not a life. It's something you want to hold with you right now because that anxiety gives you, I don't know, adrenaline on the stage, great. But it's not who you are, and it's not how you live your life. And number 2, imposter syndrome is a given. Now, I love this one, okay, because don't assume, okay, 70% of people have imposter syndrome. Assume you have imposter syndrome, right? Assume you're in the majority. And assume it's very difficult to get rid of. You don't need to get rid of it, okay? Just take it as a given. Assume you're going to fail, right? The imposter in you is saying, I'm going to fail. And because you're afraid to fail, you have anxiety. Uncertainty gives you anxiety. So take out the uncertainty. I not might fail, I will fail. I am going to fail, and now I can prepare for it. And when you take out the uncertainty, then you take out the anxiety, and the whole experience is not as scary. I want to give you a very cogent example from my own life. Again, this is the first time I've spoken to a really big professional live audience. And there was a bit of a miscommunication. There was a bit of a technical glitch. And the slides behind me were not the most updated version. And all of a sudden, I turned around to point to something on the screen that wasn't there. So first I panicked in my head and took a deep breath and made something up. And when this was all over, I had that external validation. A lot of people came up to compliment me afterwards and all of that. And I felt terrible. And I spoke to my mentor and boss at Fundbox and told him that I had failed. And he said, you not only didn't fail, you didn't even get an A, you got an A+. And why is that? Because if it had gone off without a hitch, if it had been perfect, that's an A. Lots of experienced speakers can get an A. The audience thinks you got an A, but the organizers who invited you know that you succeeded in the face of adversity. That failure was an opportunity for a plus. That had everything gone perfectly, you wouldn't even have had the opportunity to reach that level. So failure is where the extra credit is. The people who mattered and who would invite me back knew that I went above and beyond only because there was a glitch. And number one, imposter syndrome means you have arrived. It's a good thing. It's a badge of honor. It's an award. You don't get imposter syndrome buying milk. Anyone can buy milk. That's not a big deal. But if you're afraid to get on a stage, by golly, you're getting on a stage. I mean, you really need to stop and think that if you're concerned about that job you're about to take, you got that job. If you're concerned about the speech you're about to give, you've been invited to give that speech. So instead of seeing it as a bad thing, see it as a check. I'm there. I've made it. And that's winning. Love me a GIF. All right, so we talked about 6 ways that we can use our minds to control this sort of imposter syndrome, which is a paradigm, a mental paradigm, right? How we're going to use mental models to overcome our self-talk. Now I want to give you action items. Actual action items. I want you to do these things. Everyone, do these things as soon as this talk is over. Number 6, right? We thought about 5, but now we're going to do 6. We're real go-getters. First of all, own it. Use your words to own where you're at. It's okay to say, I'm new here. It's my first time. What would you do? If you're new as a junior in a junior role, you're not a fake senior. You're an authentic junior. Own it. It's okay. But what you're not going to do is apologize for being a junior. You're not going to regret who you are, right? So no sorry, no just. And what I mean with action item is right now, go to your emails. Well, not right now, when I'm finished talking. Go to your emails, go to your sent mail, especially the women, and see how many times you apologized for something that you didn't need to apologize for. How many times you added the caveat of, I just wanted to know. What's wrong with I wanted to know? What is wrong with that? Okay? And a specific tip is when you're thinking of writing, sorry this took so long, replace it with thank you for your patience. The recipient feels good and you look stronger. Number 5, use second person. So this is actually really interesting research that was presented by Adam Grant in a podcast I love called Work Life. Talk to yourself in the second person. I don't know why this works, but it does. So what the hell, use it. It means that before I got up here in front of you today, I didn't say, I can do this, I got this, I've done this before, I'm gonna be okay. No, I said to myself, Yael, you got this, you can do this, you've done this before. Again, I'm not sure why it works, but the research shows that it's better to talk to yourself in the second person, that it's that much more effective. So start doing that today. Number 4, get a community, get mentorship. And you're the last audience I need to tell that to. If you're here today, then you are blessed to already be part of a community, most likely. And this is important to differentiate from external validation. This isn't in order to find other people to tell you that you're worth it, but rather it's about hearing about how others who have lived your experience, to be less isolated, to hear, you know what, they went through it and they succeeded. How did they do it? When did they do it? And just to look around and see, kind of together with we're all faking it, we've all been there, but we've succeeded, they've succeeded despite it. So there's a lot to, it's very comforting, and you can learn a lot just from being a part of a place where everyone is experiencing that same imposter syndrome and powering through it. Number 3, and I mean it, apply for something. Right now, today, before you go to bed tonight, apply for something, anything. Google your field and apply for it. There's a conference in my field. It's actually the premier UX writing conference in the world called Button. And when I saw the first year, 2020, the keynote speakers they were putting up there, I said, oh my God, it's all the thought leaders on my Twitter feed. I could never share a stage with them. And then I found out that they so care about the integrity of the content and specifically want to give voices to newcomers and new perspectives and fresh eyes that the first screen of their proposals is blind. There are no identifying details on that very first proposal that you submit. And that made it less intimidating. And not only was I accepted to speak at Button 2020, in October I'll also be speaking at Button 2021. Number 2, pitch something. If there isn't a thing to apply for, create one. So there's a conference, one of the 2 big UX conferences in Israel is called UX Salon. And I didn't pitch me, I pitched UX writing. I spoke to the organizer and I said, your conference is missing something. Let me pitch you an idea. And not only did he then ask me to come speak about it, he created a sister conference called UX Salon Words, and I spoke there. So you can apply to things that don't exist by pitching them. It all starts by starting the conversation. Network without a specific goal. I didn't speak to him with this goal of getting a gig. I spoke to him to speak to him, to start the conversation, to let him know that he has a gap in his value offering, obviously, in a friendly and in a respectful way, and look where it led. And remember, side note about networking, if we've already brought it up, successful networking is about giving. So you don't go to, the line in the buffet at a conference and pick up a conversation with the person next to you hoping they'll offer you a job. Ask questions until you understand how you can help them. Even if it's telling them the best sandwich shop in town because you're from here, give what you can, and those are the relationships that will pay you back tenfold in the future. And number 1, and please do this today. If there's nothing else you take from this talk, today, get visible. Don't wait until you feel established. Don't say, but I haven't done anything yet, so I have nothing to publish. I have nothing for people to see. It's not true. This is an image of me giving a tiny talk only within Fundbox, only Fundbox employees. It's in the cafeteria, for goodness sake. And I put this photo all over all of my social media accounts. I wanted to be seen way before I was established, and everyone has got something they can show. Anything, put it out there, and it's a self-fulfilling prophecy. It becomes a positive feedback circle. First you're visible, then you'll get offered those opportunities to lead you to feeling more established, and it'll go round and round. It has to start somewhere. Thank you so much for inviting me here to speak with you today. I hope it's been valuable. These are the different places you can reach out to me if I can answer any questions in the future. Good luck.
Hi everyone, I'm Anat, and I'll be talking today about the challenges of resolving prospects and customers' identities. Let me start with a story. Let's say that a few weeks ago, a colleague of mine at work told me about this really cool shop where I can buy rubber duckies online, and it's called rubberduckies.com. So I was browsing through that website and looked at my shop, and all of that was done on my work laptop. But then after a while, I got back to work. On my commute back home, I got back to that shop, this time on my mobile phone. I might even added one of those rubber duckies to the shopping cart, but then I got back home and forgot all about that. A week later, my best friend was having a birthday, and I recalled how much she loves rubber duckies. I was sure it was the perfect gift for her. Now, think of this story from the rubberduckies.com perspective. They would really like to sell me that rubber ducky. They have their marketing department trying to convince me to complete that purchase. They want to know who I am so they can offer me the best rubber ducky for me. And yeah, well, in real life, this challenge is shared by many companies. Today, I would like to tell you what we did at Next Insurance to solve this challenge, so we can offer our prospects and customers the best insurance policies for them. And I would also like to tell you how we used graph databases as the base technology for our solution. But first, a few words about myself. I lead a team of data engineers at Next, and my team is in charge of all marketing-related data in our company. I love solving data-related challenges, and I've been doing it for quite some time. Next Insurance is an insurtech company which insures small businesses in the US. So marketing and data challenges, well, that's what we're going to talk about today. And what is that challenge? So as I mentioned in our rubber ducky story, we at Next face the same problem when we're trying to sell an insurance policy to our prospects. In a world where people are using multiple devices with multiple sessions, we get different cookies and tracking identifiers for our prospects. The even bigger challenge is that as an insurance company, we have two kinds of users. First, we sell our insurance products directly to the small businesses. So they come to our website and buy the insurance policies themselves. But we also let insurance agents to use our website, and they use it to quote multiple clients. So they do that very often with the same device and even the same session. Another challenge is that we insure businesses and not people. So we may get multiple contacts in a business, which eventually represent in our world the same customer. And then finally, for marketing purposes, we use prospects and not customers. And that is, we have very little information about these users. So how did we try to solve this challenge? First, we tried a default solution. We thought, that's easy. Let's just use a relational database. We're all data people, and that's the natural solution for us. We're very used to using those relational databases. So we thought that this database will hold all of our sessions and tracking data, and we will try to use it to identify who the prospects are. So we were using tables and joins to model our data. But that didn't work that well. We ended up with using super complex queries, and we were trying to identify who our prospects were using those queries. We were trying to figure out what their journeys at our website was, and maintaining this logic was a true nightmare. So every time there was a change in the product, it required major refactoring to support the business change. So then we started to think, what are relational databases actually good for? So relational databases are really good at searches. If I'm trying to get all the employees whose last name is Smith, for example, then I'm probably using the right tool for the job. Relational databases are also very good at aggregations. And if I'm trying to figure out what was the total sales amount for my orders, again, I'm probably using the right tool here. But these weren't the kind of challenges that we were facing. We were looking for the right tool for us. So we decided to look into graph database technology. And what is a graph database? A graph database is designed to treat relationships between data as equally important to the data itself. And if we have some terminology, in a graph database, data are stored as nodes and relations. So some relations have a preferred direction, but some are mutual. When querying a graph database, you can query for specific nodes or for specific relations. And one of the strongest features is that you can query nodes through their relations. And what are the graph databases good for? For starters, relations. If you're asking if Paul works with Anna, then this might be the right tool to consider. Another question that you might be asking is about pattern matching. And if you're asking if Jay Smith is actually the same person as Jenny S, then maybe yes and maybe no, but maybe using some other identifier that connects them, such as phone number, you would know the answer to this question. In that case, a graph database would be a very good tool for you. Graphs are also really good at answering centrality, clustering, and influence questions. So if you're wondering who's the right person to contact on LinkedIn regarding that job posting you were really, really interested in, then a graph database could be the right tool for you. So after we reviewed these scenarios, we definitely thought we had a case for using a graph database. And we thought it might be the right tool for identifying our customers. And we started by modeling the data. We had to think which nodes we should use and what relationships will connect those nodes. We defined our major data points, such as cookies and tracking sessions. We also used emails and other user identifiers whenever we had those available. Then we had to define the relationships between those nodes. So for example, the relationship between a tracking and a cookie was defined such that the tracking was using a specific cookie. And remember those agents that were purchasing on behalf of their clients? Well, we had some major data issues in those cases. An agent which was using the same device was very often causing data clustering, and that was unwanted in that case. So we wrote some heuristics to identify the data issues, and we ended up cleansing those. What we did is broke the cluster by deleting some of the unwanted relationships. As a note, we update the database continuously, but we identify the issues and run the cleansing jobs periodically. We ended up with a graph database, which represents our customers and our prospects' identities. This graph, it really revolutionized the way that we were able to identify related prospects and customers and businesses. It is now very easy to maintain, so it grows and easily adapts with our product changes. And this graph revolutionized how we can identify our prospects, and it supports the marketing business case in multiple ways. Let's see some examples. So attribution models. In marketing, we very often use attribution models to optimize marketing campaigns. Simplistically saying, Let's say that you have a user that saw an ad on YouTube and then they clicked it. Then they saw another ad on Facebook and they browsed your website for a while. And maybe a few days later, they search for you on Google. And then they ended up purchasing that insurance policy. So how do you know which ad was the most influential in their purchasing decision? Or in other words, how do you optimize your marketing budgets so that the best ads are served to the right customers? At Next, we now use a graph database to connect all those customers' touch points. And those are used for marketing campaigns optimizations. Another example is marketing audiences. Now that you have your prospects or customers properly identified, you can use that information to create marketing audiences. You can use the most impactful ad to the right prospect and send them the message so they will consider buying that insurance policy. The possibilities for using a graph database for user identities are actually endless. One other example is for identifying frauds in claims. You can identify fraudulent behavior by linking to customers that are filing an insurance claim. Similar claim patterns may lead to fraud investigations. Think, for example, of a case where a person was filing a claim and then they would open a new business and file a new claim with a new identity. You might end up identifying that they were the same business by looking deeper into those claims. So you might look at the address, phone, the business type. You would decide they were the same person, and you might look into a fraud investigation there. So to summarize, whenever you're facing a challenge, start with understanding your challenge. Start with properly identifying what it is and make sure you go over the possible solutions for it. Use the right tool for the job. Select the technology you want to solve the challenge that you're facing. As we saw here, relational databases are limited and weren't the right tool for our challenge. There are other databases out there, such as a graph database. The graph databases can solve a variety of problems such as relations, pattern matching, and clustering. And of course, a graph database can very easily revolutionize marketing optimizations and much more. Oh, and that rubber ducky? Well, my best friend absolutely loved it. Thank you.
Hi, you know those times at work when you are deeply engaged into a coding task and you just can't remember the next command name? Or that one time when you are texting your friend trying to figure out what will be your next meeting location, and you start typing Central Park, and Google just knows exactly where you need to go. So then, when you are finally there, you all start to daydream about your next vacation together. All types of questions are come to mind, and Google seems to know all the answers. So the most important question: when will it be safe to fly, travel, or get married again? And you decided that it's safe, and you hop on a plane and fly to your favorite destination. So when you are finally there, you start asking and thinking, what should I do? And you start typing, what are the best places to go? What will be the weather today or tomorrow or this weekend? And we only typed the letter T. And without even typing the whole query, Google seems to understand exactly what we want. Can it read our minds? Well, not yet, but for now we have autocomplete. So search is one of the most important features we have online today. Users have come to expect certain search functionalities, such as autocomplete, from sites and apps like Google, Amazon, LinkedIn, Facebook. And a key advantage of the word prediction is that it helps users arrive to better search results and improve their experience online. Hi, my name is Shani Gerstein, and I'm an NLP data scientist at GE Healthcare. I founded the NLPIL community a year and a half ago, and we currently have over 1,400 NLP practitioners who share their questions and ideas, and we are meeting also on a monthly basis, virtually for now, and I hope soon it will be face-to-face. I'm also a core team member and a mentorship program manager at Ba'ot, which is the largest community of women in R&D here in Israel. So let's start with some fun facts. 3.5 billion, that's the average number of Google searches per day. Mobile devices accounted for 63% of that in the US alone. That's a lot of autocomplete engagement. Autocomplete is especially useful for those who are using small devices. When predicting the next word for us, we won't have to type the entire query. So for both mobile and desktop users, it's a huge time saver all around. And how much, you ask? Well, Google researchers claims that it predicts save 25% of typing time and 200 years of typing time in total per day. That's amazing. So search engine predicts the user query and provides suggestions as they type, without having to type every character manually. The idea that a machine can predict the word for us based on our previous context is really fascinating to me. We can find autocomplete in apps like our web browser, in our coding editor, and Outlook and Gmail application. So how does autocomplete benefit with users? It speeds up the search process. Users won't have to type the entire complex query. They will get contextual suggestions to ease their experience online. It will provide successful queries, so no result page is less likely to occur. And it enhances the user experience. It will lead to more enjoyable and higher customer satisfaction. So there are different approaches of implementing next word prediction. In all of them, the steps will be selecting of the language model, data preparation, which includes tokenization, cleaning, and we'll discuss more about it later, and creating the model, and of course, evaluating it. So language prediction begins with selection of a model. Language model is a core component for modern NLP tasks. It's a statistical tool that analyzes the pattern of human language for prediction of the world. NLP-based application uses language models for a variety of tasks: speech recognition, spell correction, and summarization. The most common methods for developing next word predictor are n-grams, LSTMs, and of course transformer-based models. Currently, transformer-based models, which use self-attention as a method of language generation and prediction, are the ones most successful in this field. However, these models are difficult to train without a huge amount of data and without a good amount of GPU or TPU. Therefore, I will review the next two options. An n-gram is a grouping of n tokens. For simplicity, let's consider n equals 2. In this scenario, n-gram will be called bigram. So in the second row, we can see 5 bigrams. In the sentence either my way or no way, we'll have either my way or no, and no way. We will estimate the probability for the next word given the previous word. After calculating the probabilities for each word, we will choose the best suggestion based on maximum probability. Let's review RNN and LSTMs. These next two examples will illustrate how they are connected. In the first example, let's see what we remember most about Legos. So some of us will say we remember that we built the Lego according to the instructions. Some of us will say that we build it out of our imaginations. Next, there will be a group of people who are always searching for that missing piece. But most of us will remember that they were screaming in agony after stepping on a Lego brick while barefoot. An LSTM network is a type of recurrent neural network that learns dependencies on historic data for a sequence prediction task. RNN model provide a way to not only examine the current input, but the one that was provided one step back as well. Let's review another example. That example will emphasize the need for LSTM. In the first sentence, the grass is always. The next word is simply green and could be predicted by most models and networks. But for the second sentence, it's winter and there has been little sunlight. The grass is always. So here we need to know context from further back in the sentence and to predict the next word as brown. RNN and similar model will be less accurate in this case due to the gap between the context and the word to be predicted. Here is when LSTM will be beneficial, since it has memory cells to remember the previous contents. So LSTM introduced a new structure, the memory cell, and it composed out of 4 elements: the input, forget, and output gates, and a cell state, which is a neuron that connects to itself. The forget gate determines which relevant information from the previous step is needed. The input gate decided what relevant information can be added from the current step. The next step is to decide and store the information from the new state to the cell state. And the output gate finalized the next hidden layer for the next cell. When building our model, the first step will be data preparation. In this step, we will clean and tokenize the sentences, lowercasing it, in order to continue with the model. Next, we will have the embedding layer, which is initialized with random weights and learned embeddings for all of the words in the training dataset. The 2 LSTM layers are followed by 2 fully connected layers. The second one, the last one, is our output softmax layer. And it has the number of units equals to the vocabulary size. For each input, the model will predict the next word from our vocabulary based on the probability. We will consider categorical cross-entropy as the loss function. LSTM recurrent network can be slow to train, and it's highly recommended that you will train it on GPU hardware. It's crucial in the area of deep learning that there is a consideration for the trade-off between model size and performance. Being resource efficient should be the goal rather than improving the accuracy by 0.01%. How would we know if our prediction was accurate? In order to evaluate the performance, we can consider two methods, quality and quantity metrics. Quality-wise, in cases there wasn't any exact matches, it's crucial to look at the sentence structure and the context of the predictions. Quantity-wise, word perplexity, which is a calculation of the exponential of the loss, measure how confident the model is in predicting words. It's actually the quality of the text results, how surprised or perplexed the model was to see the output given the input. A lower perplexity score means that more information about the sentence is conveyed to us. We have a couple of more metrics for the quantitative part. Exact match at n, which shows at which level of probability we are predicting the correct word, if at all, and of course precision and accuracy. We cannot complete sentences with a button press during a lecture or a live conversation just yet. For now, language model can help us while texting or finding information automatically. We talked about language models and how we can use this type of representation to infer the next word. Using LSTM model to capture the previous context of the sentence we would like to complete, and the evaluation metric to measure it before you go live with your next word prediction application. Language understanding and generation practices continue to advance day to day. We are definitely experiencing an exciting time in technology. The work that goes behind the scenes to make your user experience smooth and seamless is enormous. I personally can't wait to see what's coming next. I hope that after hearing this talk, you will see words suggested by Google or your phone keyboards in a new light. I would like to invite you all to join the NLP community, discuss more interesting topics like this one, share your thoughts and recent studies, and network with fellow NLP practitioners. Thank you very much for listening. I'll be happy to answer your questions or comment, and I look forward to seeing you in the NLPIL community.
Hi everyone, and thank you for joining my talk today. I'm going to talk about all these goodies or why classical machine learning still rocks. Hi, my name is Dorit Baras. I'm a senior algorithm engineer in Medtronic Yokneam. I have over 15 years of experience in machine learning, deep learning, image processing, and computer vision. I have bachelor and master's degree, both from the Department of Electrical Engineering at the Technion, and I love Hello Kitty and rock concerts when available before COVID. These are pictures from my private collection. So let me tell you how the idea for this talk started. As part of my work, I supervise industrial projects. It's a collaboration between Medtronic and the Department of Computer Science in the Technion. We offer topics for projects, and we provide the data and computational resources, and undergraduate students work on those projects. Usually the projects that I offer are deep learning projects on Pilcam data, and students are very enthusiastic about it. I usually suggest that in addition to the deep learning model, the students will also train a classical model or a hybrid model, and this is the response I get. The students tell me, seriously, do people still do that? I mean, we have deep learning today. We can do things that are so accurate and have all those amazing details. And I tell them, yes, that's right. But sometimes we want something that is quick and dirty, that it's lighter and easier, and we can understand better what it does. And the fun part is that we can combine them into a hybrid model that outperforms each one of the models separately. So today my mission is to convince you that classical machine learning is still relevant and it rocks, and I urge you to use it. The continuation of the talk is as follows. I'm going to provide a very brief history of machine learning, and I want to emphasize that I am going to concentrate on classification algorithms only. I'm going to talk about the pros and cons of each approach and the considerations for deciding what to use when. And I will show a few concrete examples. Okay, so this is a histogram count taken from the review process for NIPS at 2016. NIPS is one of the two largest machine learning conferences. And at 2016, the top 3 topics were deep learning, computer vision applications, which is another nice name for deep learning, and large-scale learning and big data, which is another fancy name for deep learning. So we know that there has been an explosion of this technology starting at 2005, mainly by Hinton, LeCun, and Bengio, who were also the winners of the award in 2018, the Turing Award, for their contribution. But it started much earlier, in the early 40s, when Hebb presented the concept of a neuron, like the brain cell. And then in the late 50s, when Rosenblatt presented the perceptron, the first linear classification algorithm based on the idea of the neuron. In the mid-80s, the backpropagation algorithm was presented, and it is used to train artificial neural networks, which are considered the ancestors of today's deep learning. In between, there were other classification algorithms, such as the support vector machines and decision trees. Okay, let's talk about the pros and cons of each approach. So data. We can start training a classical machine learning model with only a few dozens of examples, and we can also train on a few hundreds of examples. Usually when we get to the area of several thousands, we are going to have to downsample. We can start training a deep learning model with a few hundred samples, and the sky is the limit. Interpretability. So classical machine learning offers, in many algorithms, ways of interpreting the model. For example, in decision trees, the nodes correspond to specific features and the thresholds. And by looking at the structure, we can understand which features are more important than others. Another example is in linear support vector machines, where we can analyze the values of the weights which are proportional to their importance. However, in deep learning, the interpretability is limited. We have millions of parameters, and understanding the exact values of a certain convolution layer will not help us understand why the output of the network was a cat and not the dog. Computational resources. So classical machine learning requires a strong GPU, while deep learning requires a GPU and a lot of memory. And the performance, so in deep learning, they can even outperform human level and achieve great results. And in classical machine learning, they can be moderate. Okay, so how do we know what to choose and what to use when? So the first question we need to ask ourselves is regarding the volume of the data that we have. So as I explained earlier, when we have several dozens examples, we usually use classical machine learning. When we get to the area of hundreds, we can use classical machine learning or lots of augmentations and then deep learning. When we get to the area of thousands of samples, we can sub-sample and use classical machine learning, or we can use deep learning. And when we get to the area of many thousands or even more, we use deep learning. The second question relates to the type of data that we have. If we have tabular data, in tabular data, each row corresponds to a sample and each column corresponds to a feature. This is a concrete example. So this is classical for classical machine learning. This is the raw data that most classical algorithms accept. So when you have tabular data, use classical machine learning. For images, it depends on the exact task. We can either extract manual features and represent each image as a vector and feed those to classical algorithms, or we can take the image as is as an input to a convolutional neural networks. So here again, we can use both. Video streams usually have a lot of data, so deep learning is more appropriate. And in text, again, it depends on how much data we have. If we have a large corpus of many Wikipedia pages, then we're going to need deep learning. But if we have few sentences or clusters of words, then classical machine learning is enough. The same goes for time series. If we have the value and the price of a product over time, regression can be enough. But if we have months worth data of EEG, then we're probably going to need deep learning. Finally, when we have mixed models, again, depends on the task, but many times it calls for hybrid models that combine both technologies. The next question relates to the domain knowledge. Do I have enough domain knowledge to extract the features or even to label or annotate the samples? For example, if I want to train a model that will distinguish between cats and dogs, I know that I can extract features such as the shape of the ears or the length of the tail. Or if I want to distinguish between apples and bananas, I know I can look at the color or the shape. But if, for example, I get medical data like MRI data, I personally wouldn't know which features are relevant. And given an MRI image, I wouldn't know if this patient has a tumor or bleeding. The next question relates to the interpretability. As I mentioned earlier, it's almost impossible with deep learning. So here you see an example, a real example from a paper about predicting diabetes risk with a decision tree. You can see that the features are glucose and insulin and age and so on. And by looking on the tree, you can understand the risk factors and understand why a decision is made. You also see the inception network. It is well known and commonly used. But if I tell you that what are the numbers in one of the specific layers, it's not going to help me understand why the output is a cat or a dog. Next question relates to the technical constraints for training and for inference. So training a classical model can take a few seconds, a few minutes, maybe a few hours. Training deep learning model usually starts with a few hours, but it's typically days and even weeks. And where classical models require CPU, deep learning requires GPU, at least for training. I will say that there are networks that are small enough to run on mobile devices like MobileNet. And a few concrete examples. Okay, so the first example is a classical use example of EMR data. EMR stands for electronic medical records. This is for forecasting type 2 diabetes. So this is tabular data, which we already said that is for classical algorithms. And they have a bit over 2,000 patients, and their features are demographic and clinical and lab values. Here in the table you can see examples of some of the variables. And the authors tried various algorithms like logistic regression and k-nearest neighbors and decision tree and so on. And the area under curve, which is our performance measure, varies in the range of 0.72 and 0.87, which is not amazing, but it can still provide the physicians with information. This is one of the trees that the authors present that they learned. You see that it only has two features, BMI and triglycerides. The second example is a deep learning example with retinal images of the eye, and this is also for diabetes detection, retinopathy, which is a disease that comes with diabetes. So here the data set is large. There are 35,000 samples, and the users use an ensemble model. It means that they train several deep learning models in parallel, ResNet, inception, exception, and so on, and they take their average prediction as their output. So here you can see that the area under curve is higher than what we've seen earlier. The results are good, and also the confusion metrics. The third example is a hybrid example of mammography and EMR data combined. Here, each sample is 4 mammography images and the corresponding clinical data. There are 10,000 patients, so there are around 40,000 images. They had 2 objectives here: to classify whether or not this patient has cancer, and category of the mammogram, whether it's normal or abnormal. And I'm not going to go into all the details, but I do want to show you some parts of their system. So in the first stage, they used classical algorithm for feature selection that reduced the number of clinical features. Then they trained several deep learning models in parallel, and they used this representation and the clinical features in order to learn the model for classification of the 2 objectives. Here you can see the results. Again, the area under curves look really good. But what is nice to observe is that the blue line corresponds to results using clinical data only, and the green using images only. But the red is the combined. And this is an example where the hybrid model outperforms each model separately. Another example that is also relates to classification of diabetes retinopathy. I won't go into details. I just want to show you that here the authors used feature extraction using deep learning, and then this was fed into a classical model of support vector machines. So let's summarize. Classical machine learning is still relevant, and it has many advantages. I urge you to use it as much as possible. Deep learning is amazing. I don't think I need to add further. And you can use deep learning as part of a hybrid model. You can either use the deep learning output scores as features with additional features, or you can learn a representation using deep learning and use that as an input to your classical model. Thank you. I'm available for any questions.
Hi everyone, before we start, I just want to make a small disclaimer. This lecture is not for you if you always implement the most cutting-edge solutions and never think about the simple one. This lecture is also not for you if you're completely blind to the client's needs. Also, this lecture is not for you if you cannot see the big picture. And if business KPIs make you fall asleep, you better just move on. If talking to the product manager makes you feel sick, we better separate now. And if everything looks like a nail for you, we better just end now. But if you stayed so far, hop on board because we're going to a fascinating journey together. So hi, I'm Dana and I'm the head of data science at Pick-a-Peer. I also serve as a data science advisor for various startups. And my biggest passion is solving hard problems with the most simple solutions I can find. So our journey today actually begins 20 years ago, when this was a very popular picture, when you had to go to a tourist agency in order to book your flights. I remember the last time I went to an agency like this, and it was in 2010, I think, when I had to get my visa to Nepal. Luckily today, we can just reserve all we need online, and we can even pick our seats. I also wonder how many of the hotels still look like this. I bet most of them looks like this, with much more technology. In the maritime domain, this is how it looked like 20 years ago. This is an inventory management system. And this is how it looks today. Yes, the same thing. I mean, until we at Pick-a-Peer enter the game. So at Pick-a-Peer, our product tries to answer all the needs of our clients, meaning helping the boaters make reservations, helping marinas manage their inventories, making simple communication between both sides, and so on. But actually today, I want to talk with you about a specific problem, the matching problem. This problem I had to solve when I first got to Pick-a-Peer. The problem is matching between boats that come into the marina and available berths. A berth is actually an anchoring spot inside the marina. So while I was thinking about this problem, I actually realized it's very familiar to a game we all have to play, the Tetris game. And the same as in Tetris game, that we want to maximize some kind of score function, also in the maritime domain. But the problem is that we never know what shape is going to get next. The same is for marinas. They never know which boat is going to reserve a spot next. So before we dive into my algorithm, I just want to share with you the product requirements. The first product requirement was first comes, first served, meaning that we're not running a mafia here and we actually want to serve our clients decently. So if a boat was promised a spot inside the marina, we don't want it to arrive and then it appears there's no spot for her. The second requirement was that allocating the specific berth is going to be made only one day before the boat arrives. The purpose of it is to allow the marina as much flexibility as possible. So in order to answer the product requirements, I had to think about the algorithmic assumptions. The first assumption was that every marina has a constant number of berths, since it's not a one-day job to build a new pier. The second requirement was that every marina has its own business goal. meaning that my algorithm had to have a very flexible cost function in order to answer different business targets. For example, one marina may want to optimize its revenue, another marina may want to maximize its occupancy, and another marina can want to maximize her prestige, for example, by serving mostly super yachts. The last assumption was that although I really wanted to implement cool algorithms such as reinforcement learning, I had only a few dozen of samples of reservations and birds when I first started to work on this problem. So I realized that I have to implement actually a very simple algorithm. Back to the Tetris game. What if while we're playing, we could just take the shape we get and place it, switch it, swap it with another shape that is already appearing in the screen? Yes, this is exactly what I've implemented in our matching algorithm. So you can see here the entire algorithmic chart. But before we dive in, I just want to tell you that behind the scene, there is a really complex mathematical equation, not like this one, that takes into account all the necessary parameters, such as the boat dimensions, the bird dimensions, the boat prestige, the duration of the reservation, and so on. And just if you thought of stealing my idea, no, I'm just kidding. Just wanted to know that. And what else I want to mention is that the colors have meaning. The blue color represents the pool of the reservations in the waiting list. The mustard color represents the matches pool, which contains reservations which are already matched to birds. The purple color represents the pool of available birds. Now that we got it, so let's start with the common practice. You can see in the left side. So in the common practice, what happens is when a reservation get to a marina reception by phone or by email, the receptionist usually just can look out of the window and see if there is available bird currently, and if not, the reservation is rejected, and usually no waiting list is offered. But in our algorithm, in Pick-a-Peer's algorithm, it's completely different. When the reservations arrived, the reservation entered to the system automatically. So the algorithm searches for the bird that match it the best, meaning it optimizes the cost function. So if no match is found, the reservation is going into the waiting list. But if a match is found, then the algorithm does another step of optimization. It tries to swap the new match with another match which already exists. And if this swap would optimize the cost function, then now boat A would be matched to bird B and boat B with bird A. The last part, but not the least, actually this part is the one that mostly contributed to optimization function of the algorithm, happens like this. When there is an available bird, it can happen, for example, if someone just canceled his reservation, then this bird, the algorithm tries to match this bird to a reservation inside the waiting list. So if the match is found, we're going back to the matching cascade we talked 2 slides before. But if no match is found, we still got an available bird. So the algorithm can take another optimization step. Now it tries to swap this bird with already occupied bird, which is matched to another reservation. And if this swap is going to optimize the score function, then the algorithm makes it. and then the new match is added to the match pool, and the free bird is going to the birds pool. So I think so far I managed to convince you that this is actually a very, very simple algorithm, but yet very sophisticated, because it fits perfectly to our maritime domain and answers all the product requirements. And I just want to finish with this lovely meme that was shared by Paige Bailey, which is a familiar data scientist from the industry. Tell me the truth. I'm ready to hear it. Most of the time, you won't need deep learning. Most of the time, you won't even need machine learning. So thank you so much, and I'll be really happy to answer your questions in the chat. Bye-bye.
Hi, my name is Sarit Roizman, and today I would like to give you all a 15 minutes glimpse, maybe your first, into the fourth industrial revolution. So as I said, my name is Sarit. Nice online meeting you. I'm a chemical engineering bachelor, a manufacturing engineer at Medtronic, a proud WISE member, woman in science and engineering, and a family economic advisor. To shake things up, in my lecture today, I will not talk about some new state-of-the-art implementation of AI or a machine learning algorithm. Instead, we will go into what can mistakenly be considered as low-tech, and I will present you the huge advantage of smart industry formed by those algorithms from my point of view as a manufacturing engineer. I must admit that I'm so excited to speak here today, and as the song says, I just can't hide it, and soon you will all understand why. So, in this lecture, I will introduce you the fourth industrial revolution and the revolution that came before. There is a wide range of uses for Industry 4.0. I've chosen to introduce you one of the more useful aspects for me as a manufacturing engineer, troubleshooting. The method today, its problematic nature, and how smart industry addressed it. Finally, I will provide a glimpse to the Industry 4.0 in Israel. Let's quickly review the revolution that came before. The first one was using machines that operates on steam power and water power. The second one, the transition to mass production, assembly line, and electricity. What a wonderful discovery. The third one was using computers, electronic components, and automation. Each of the past revolution has its respectable place in history. Our lives have changed and improved dozens of times thanks to them. With that being said, production capacity has grown rapidly, and with great new industrial power come great new challenges. With that introduction, let me present you the fourth industrial revolution, the information revolution. Warning, long sentence ahead. Advanced microsensors, ultra-fast wireless connectivity, cloud computing, and advanced AI and machine learning tools all come together, connecting multiple cyber-physical units into one smart, autonomous, more than ever decision-maker production line. As I said, there is a wide range of uses for Industry 4.0. Improvement and optimization of the process, cost saving, manufacturing investigation, and product development. In this lecture, I have chosen to present you an example of a manufacturing investigation. So, complaints arrive. Automatic sequence of action starts. Collecting data to identify the problem. Taking a temporary countermeasure on the spot. Investigation to find the root cause. And finally, solutions. Proposing a solution, establish an action plan, and checking the result. Sounds perfectly logical. So what's the problem? The problem is expectations versus reality. Many times the relevant data is a month or years old and not digital. Many times the relevant data is not exist at all, and we must rely on memory, employee experience, and assumptions. Finding the root cause requires investing resource, performing experiments, and many times shutting down production. The same with examining solutions. Returning the production plan to track not always correspond with the physical capabilities of the materials, the equipment, and manpower. In short, data collecting, analyze, and use performed by people from their point of view without the big picture is available for them. By the way, do you know the difference between information and data?
information is driven from data. Without complete and accurate data, we cannot proceed towards the solution. Production lifecycle. I cannot emphasize it enough. A productive production lifecycle contains many parts: supply, process, operation system, computer, customer, product, people, and more. All those parts need to work together smoothly and simultaneously. If one wheel squeaks, the whole system is in danger of stopping. So how does Industry 4.0 address those issues? In Industry 4.0, each part is related to another. Gear system, remember? Therefore, I will divide my answer into 3 parts: data collection, problem solving, and preventive action that all occurred in parallel. Data collection. Imagine a situation where all of the data is digital accessible. You know exactly where and when each employee worked. You know what were the status of the equipment during production, and you know what were the results for each product at every test. You can locate the faulty product and isolate the problem. Problem solving, or how to fix the actual problem. Performing a digital simulation on a twin system using the collected data to mimic the condition during the fault, to understand the malfunction. At the same time, the logistic leadership will plan a new feasible production strategy: material, manpower, equipment capabilities. Preventing action, or how to prevent a similar problem from occurring at the future. Improving the training process. Production employees and end user using a AR/VR training. Improving the process using a 3D printing, predictive maintenance, and automation. Following the holistic view of the fourth industrial revolution, we address not only the fault, but also the raw material, the human material, the process, the equipment, and of course the logistics system. While all of the information is transparent and accessible to decision makers. There are currently more than 200 companies in Israel that are related to the field: robotic and automation, sensors, AR, VR, AI, and many more. Many factories have already started their first steps in the field to become smarter and more efficient. One example for predictive maintenance is Philip. Philip is a company that grew within the walls of the chemical and material engineering faculties at the Technion. Their product consists of flexible, non-invasive nanomaterial stickers, sensors that attach to any equipment with wireless communication units and AI-driven cloud analytics. The system alerts anomalies in advance, prevents downtime, and cuts maintenance costs. So here's an example for a company that ticks many of the right boxes: advanced sensor, AI, cyber physical system, and IoT. Just like in the picture, a company that fails to do the technological and mindset change will remain behind. And with these words, long live the revolution. Thank you.
Today we're going to go on a journey together. It's the journey through the history of recommendation algorithms that I myself went through when I started to work at Outbrain. I'll attempt to present this journey in 15 minutes. I'll start with some basic background on what are recommender systems, and then I'll present 3 algorithms: logistic regression, poly2, and factorization machines. And finally, I'll present one of the cutting-edge classical algorithms called field-aware factorization machines, or in short, FFM, and show why it beats them all. Hi, I'm Adi Schwartz. I'm a data scientist in Outbrain. I develop machine learning infrastructure, as well as research, develop, and deploy machine learning models, and I love trekking high and snowy mountains. Netflix, Spotify, Outbrain. What do all these companies have in common? They all have recommender systems. Netflix recommends music or TV series they think the user will want to watch. Spotify recommends music they think the user will want to hear. And Outbrain recommends content they think the user will want to read. Very generally, the common question to all recommender systems is, how likely is the user to click on the ad? As a hiker, I really like looking into hiking gear. So let's look at some backpack ads as an example. In the table attached, you can see 4 ads as an example for backpacks. 3 of the first columns, publisher, advertiser, and volume, are descriptions of description information, and we call them features. The 4th column is called clicks or non-clicks, and we use it to calculate click-through rate, or in short, CTR. So what is CTR? CTR is a common metric we use in recommendations, which calculates the number of users who clicked on the suggestion, divided by the total number of users who viewed the suggestion. So for example, in the first row, we have 90 clicks and 10 non-clicks, so all in all, 100 views, so we get a CTR of 0.9. Without going into the optimization of the algorithm, the aim is simple. The algorithm will learn the historical ads and their CTRs, so it could predict the most accurate predicted CTR. Why? So that the recommended items could be ranked based on their predicted CTR. Let's say I want to suggest the ad I think will interest the users the most. In theory, I would like to publish the ad with the highest predicted CTR. Now let's deep dive and see how it's done. So the first algorithm I want to present is logistic regression. Logistic regression is the most commonly used algorithm in the classification world. It classifies an event if it's true or false. In our case, if a user clicked on an ad or not. If the probability of the user who clicked on an ad is above 50%, we will classify it as if there was a click. If it's lower than 50%, we will classify it as if there wasn't a click. This equation models the relationship between a feature and the predicted CTR. I'll simplify it a bit, but we can see we have a W multiplied by X. So the X here is the feature. What is the W? W is the weight or significance of the feature. The higher the weight, the more significant the feature is in predicting the CTR. Let's look at the example. We now have a weight of Yao multiplied by Yao, a weight of Deuter multiplied by Deuter, and a weight of 50 liters multiplied by 50 liters. But let's look a little bit more on the first line. We can see that Deuter, when publishes in Yao, has a CTR of 0.9. But when Deuter publishes an MSN, there's a CTR of 0.05. So there's a relationship here between advertiser and publisher, and we would like to model it well in our algorithm. But when I have an individual weight for each of the features, this relationship won't be modeled. So if to sum up logistic regression, it's simple, convenient to explain, and easy to scale, but it only represents linear interactions. So if we want to model something nonlinear, we have to manual feature engineer it ourselves. And this brings me to our second algorithm called poly2. Poly2 has the same linear equation as in logistic regression, but now it has a nonlinear term as well. again, I'll simplify this equation, but what we see here is a combination of all feature pairs, and every feature pair has its own weight, so it's a weight of both features. And again, I'll show it in an example to make it clearer. So now we have a weight of Yahoo Deutel, plus a weight of Yahoo 50 liters, plus a weight of Deutel 50 liters. So now that we have this weight of Yahoo Deutel, this resolves the issue from the logistic regression. I could have concluded this talk here. So what's still the problem? The problem is how Poly 2 addresses new data points, data examples, or data that is very few. Let's look at the example. We can see here we have low alpine. Low alpine wasn't appearing in the data train, and because of that, we didn't have a weight for it. So now a weight will be formed, but it's the first time this weight has been formed, so it's not very accurate, right? And it won't give me the accurate predicted CTR I'm looking for. So if to sum up Poly 2, it's simple, convenient to explain, and easy to scale, but it gives trivial predictions for unseen data and unreliable predictions for interactions that are very few. But I have to stop here. I kind of stretched the truth a little bit. And this table doesn't really look like in real life. So how does it look like? A little bit more like this. You can see I still have publisher, advertiser, and volume, but now it's embedded, which means there's no more categorical data. Now it appears as zeros and ones. One represents if the feature exists, and 0 represents if it doesn't. I'll explain a little bit more in factorization machines. So I want to present the third algorithm, factorization machine, or in short, FM, which uses vector interactions. So as you can see, I still have the linear term of the logistic regression, but now I have another term and it's represented by vectors. And what do I mean by that? If we look back at our metrics, we now create a vector of publisher, a vector of advertiser, and a vector of volume. And we dot productize these combinations. Let's look at the example to make it clearer. We have a vector of Yahoo with the dot product of a vector of Deutel, a vector of Yahoo dot product of vector of 50 liters, and a vector of Deutel with a dot product of vector of 50 liters. So before I want to stop here and say why this factorization machines help us against the problem we had in Poly 2. And it's because the way we have the embedding of the vectors. So because we have embedded vectors, we now have all the information of the entire dataset, which includes the low alpine that we encountered in the Poly 2. And because of that, it will give a better prediction compared to Poly 2. So what's still the problem? Let's look at the vector Deutel. The vector Deutel is used for the vector Deutel is used in two different interactions, with the interaction of Yahoo and interaction with the vector of 50 liters. So if I use the same vector to represent two different interactions, I'm still a little bit missing the point here. I won't get the accuracy I'm looking for. And this brings me to my final model, but not before I summarize this one. So factorization machines handle sparse datasets, but it uses the same feature vector to represent all interactions. So now let's go to our cutting edge algorithm called field-aware factorization machines, or in short, FFM. Before I explain what does FFM do, let's talk terminologies. So up to this point, we called publisher, advertiser, and volume features. Now let's change the naming. So publisher, advertiser, and volume will now be called fields, and their categorical information, such as Yahoo, MSN, Deutel, Osprey, Low Alpine, 50 liters, 62, etc., these will be called our features. So why these terminologies? Let's go to the equation and we'll see the diff. So we can see that in the upper equation, we had our equation of the FM, and there we had a vector combination. But FFM uses a vector with its corresponding field to make the predicted CTR much more accurate. And let's look at the example to make it clearer. So there's now a vector of Yao with the corresponding field advertiser, with the dot product of vector of Deuter with the corresponding field publisher. Then we add a vector of Deuter with the corresponding field volume, with the dot product of a vector of 50 liters with the corresponding field advertiser, and a vector of 50 liters with the corresponding field publisher, dot productized with the vector of Yao with the corresponding field of volume. So if we go back to the problem we had with FM on Deutel, we now see that we have a different vector of Deutel represented in the interactions. So with the interaction with Yao, I have a vector of Deutel publisher, while with the interaction with 50 liters, I have a vector of Deutel volume. So now that each interaction is using a different vector, it will give me this advantage compared to factorization machines. So I want to conclude. FFM is amazing, and the only disadvantage I could have thought about is it's represented only in two-dimensional interactions. So we're going towards the end of this journey, and I know it's been a dense and a quick journey, but I want to sum up again what we saw throughout our journey. So we started with logistic regression, but it only showed linear interactions and didn't give us the extra mile. Then we moved on to Poly 2, which gave us non-linear interactions, but still it didn't perform well when encountering new data examples or data that doesn't appear much. Then we moved to factorization machines, which work well with sparse data sets. But there we encountered a problem when we had the same vector representation in a few interactions, which brought us pretty close to the predicted CTR of our accuracy, but still not quite there. And because of that, we moved on to FFM, which is a bit advancement of factorization machines, which used the corresponding fields for each of the features, and that gave us the extra mile and the predicted CTR we want. Thank you very much for listening, and I'd be happy to answer any of your questions if you have any.
Why AI? Well, ever since computers could hold images and process them, we also wanted them to understand what's in the image, to know that this image contains a cat, and this is a person, a cup of coffee, and here we have an airplane. Simple task, really, but it wasn't that easy 10 or 12 years ago. Today, with deep neural networks, we can not only detect that this is a face, we can also know the emotion of this face, or to detect a specific person within a crowd. Amazing, really. Today, I'm going to tell you about this journey from the place we've been in 12 years ago to where we are today. I'm going to talk about this journey not only because I find it fascinating, really, but also because I think we can learn a lot of it for the journey we still got ahead. Hello, I'm Ori Ben-Yitzhak. I've been exploring algorithms for more than 20 years in the industry, and the last 10 years of them are in the area of computer vision. Today, I'm working at Medtronic AI Group. The three beautiful guys you've seen before are my own three kids. And I'm going to tell you about this journey because I've been there, and I think it was just great. So let's start with a relatively simple task for computer vision. It's the reading of text for natural images. By the time we had this problem on our table, the problem of OCR was already solved. Reading printed text was solved by holding a bank of all characters in many fonts and just finding the best fitting one in the bank. But you cannot hold a bank of all characters in natural images, right? It's infinity. So what do? We started by writing heuristics. Well, if it's a vertical line, probably an I, right? Or a 1. So let's look at the top. If the top is leaning leftward, it's a 1. And if the bottom and the top are identical, it's probably an I. And what about lowercase l? And the line doesn't have to be vertical. It could lean to one side or another. And L and 1 are not that easy to detect. So soon enough, we had a bunch of rules and exception to the rules, and we aggregated rules, and we created hierarchy of rules. There was a jungle of rules. And the problem was, well, fairly solved, but not great performance. And we couldn't do anything better because it was just too complex. No person can hold this entire complexity in her head. Luckily, at about this time, the early days of machine learning started to emerge. Tools like SVM, random forest, random fern became better and better, and they became quite good classifiers. One thing we should remember though, they were not image classifiers, right? What did they classify? They classified vectors. When receiving a bunch of vectors with labels, they learned something, a kind of separator or a decision tree, internal structures that help them at runtime when receiving new vector, find the best label for it. Okay, so we got great vector classifiers, but we want to classify images, right? So what do? We try to squeeze an image into a vector. We usually cut the image into small sections, and we look for numerical features in those sections, like how many gradients do we have in each direction, or how many pixels we have in each color. Or we can compare this snippet of image to a filter and see how good is the similarity between them. Or we could compare to many filters and aggregate the similarity to all of them, right? And how good is our classifier going to be? Well, just as good as the features we extracted. If we manage to get the essence of this image in those features, we're going to have a great classifier. But if we didn't, well, tough luck. SVM was already a strong enough tool to solve this problem of natural images text. Why was it strong enough to solve something we couldn't solve by heuristics? Because it found the optimal classification for us. We still had to extract features, but the classification was calculated by the machine, and it was calculated to be optimal to the data we gave it. The next huge leap forward came with neural networks. Now, neural networks has been there for a couple of decades. Most of this time, they weren't such a great tool, and they weren't used because they didn't solve problems, real life problems. The great leap forward came when deep neural networks were presented. And for the sake of computer vision, when convolutional neural networks were presented. So let's talk a little bit about what does it mean, deep neural networks, and what the hell is convolutional neural networks, right? So deep neural networks mean we have lots and lots of layers of neurons. And a lot of neurons in the net, and tens of layers and millions of neurons, maybe more. This is a very powerful tool, and it solves problems. But what helped computer vision problems are the convolutional neural networks. By the way, they were presented together. They made the big step together. So convolutional neural networks are layers that have are networks that have convolutional layers at the bottom of them. Okay, I didn't say much, right? Convolutional neural networks has convolutional layers, but what is it? So here is what it is. Please bear with me a little bit. The bottom layer, the convolutional layer, has small snippets of the network looking at different areas in the image. There's a snippet for each area in the image. And the small snippets that look at different areas are exactly the same. Not only by architecture, but also they are trained to have exactly the same weights in them. And the same weights means the same neural network. It detects the same features, okay? And what are the features it detects? Here are the features detected by the bottom convolutional layer of ResNet 50. ResNet 50 is a very popular computer vision neural network. And here are the features. What are they? Well, it's a bunch of filters, right? The same filters we used to have with SVM, but now they are not handcrafted filters. Now it's a filter that the machine calculated to best fit the data at hand. And these are just this is just the bottom layer. It contains very simple features, right? Vertical lines, dotting, things like this. But the layers above it are going to be also convolutional, and they're going to extract some more complex features, like an eye of a person, an ear of a cat, a whale's tail. And the entire network is going to have some fully connected layers above all it, and the fully connected layers will have those complex features to decide with them and classify the image. Amazing, really. We have lots of different architectures for computer vision problems and solutions, but trust me, they all have bottom several convolutional layers. So why is that? Because the convolutional layers extract features, and this is what we need. What did we have so far? Remember, we started with heuristics. We manually extracted features from the image and we manually wrote rules to classify them. And it wasn't that good. We gained more power when we switched to early days machine learning, where we still had to extract the features ourselves, but the classification was found by the machine. So we let go of the classification and we gained more power. The next huge step ahead came with deep neural networks, where we let go of both of them. Both the features are automatically extracted and the classification is automated. Letting go gave us much, much more power. So what's next? Well, I believe next we need to let go of the things we still do manually. We still do by trial and error. And what are they? We still handcraft our own architecture. We can either select from a great variety of existing networks, or we can build the network architecture from building blocks, and we try the network we assembled, and if it gives us good performance, well, great, and if not, we switch to another architecture. Well, it's basically trial and error. I believe the machine can calculate for us and find the best architecture for our problem. What about activation function, loss function? It's about the same story. We try, and if it works, great, and if not, we switch. Why not let the machine do it for us? Same for other parameters like learning rate, etc. There are already works that progress in this direction. I believe very soon we will not do it manually. There will be a new machine that will calculate all those things for us. And in the further future, well, as you all know, machine learning and deep neural networks are data addicted. They are so hungry to more and more data and more labeling. We keep doing it for them. We keep collecting data and labeling it, and the quality of the network is really very heavily depending on the quality of the data we collected. So maybe, just maybe, in the further future, we will not collect the data for the network. Maybe it will look for data itself. Thank you. I'm Ori Ben-Yitzhak, and I love to answer questions.
Hi, my name is Dorit. I'm head of data science group at Light. Thank you, Moran, and thank you, Women on Stage, for hosting this amazing event. I am really excited to present here today how we cracked the cyberbullying model. My name is Dorit Zilberbrand. I am head of data science group at Light. We detect online toxic behaviors. I have a PhD in computer science from Bar-Ilan University. My thesis was on building statistical models to detect suspicious behavior. To give you a little bit of background on myself, I have been working in the tech industry for almost 20 years now, providing algorithmic solutions to real-world problems. Why Light? I have 3 daughters. Noah, my eldest, is 13, Yael, 11, and Shira, my youngest, is 7. They spend most of their time online, and even more so since the start of COVID. They research, learn, communicate, and play interactive games. My youngest Shira knew how to use the WhatsApp recording function before she knew how to read or write. Unfortunately, this online activity comes also with risks. They are exposed to adult content, cyberbullying, and even pedophilic behavior. As a mother, I feel privileged to be able to contribute my knowledge and skills to make the online world safer for all the children, not only my daughters. At Light, we have developed a large number of algorithms, especially for this purpose. We have AI models to detect pedophilic behavior, bullying, shaming, self-harm, hate speech, etc. Developers or companies can integrate our models into their solutions using our APIs. We get inputs in the form of text, images, videos. We send them into our engine and output toxic behavior like bullying, shaming, etc. Today, I would like to focus on one behavior, the cyberbullying in text messages. So let's begin and crack the cyberbullying model. So what is cyberbullying? Before we start designing our algorithms, we must first define it. Cyberbullying is bullying that takes place online. It can take place in chats, forums, social networks, etc. It contains personal insults cause humiliations, hate, threats, and sexual harassment. In this talk, I will give examples from the personal insult model, but it applies to all the other models under the cyberbullying. Why is cyberbullying so challenging for NLP? Let's think about the way people communicate today. When my 11-year-old daughter sends a text message to her friend, she uses slang, acronyms, typos, emojis, and many other nuances. Informal language is difficult to interpret. And we all use it today. So how do you interpret an angry face or a slang like bite me? And then there are more complex examples, like you see on the screen. Understanding such sentences is difficult, also for humans. Another challenge is that the same word can appear either in a personal insult context or in a non-personal insult context. One may think that dictionaries or keyword spotting can solve our problem, but this is not the case. On the slide, you can see examples for words that appear in both contexts. Let's take, for example, the keyword hate. I hate Jane, it's a personal insult. I hate myself, this is not personal insult. Are you retarded? It's a personal insult. She think he is retarded, this is not a personal insult. And there are many more examples. The context is important. And personal insults evolve over the time.
A new personal insult that came up is, if 2020 was a person, it would be John. This is a new personal insult, and there are constantly new insults. To collect all these kind of sentences and to build our model, we developed a wash, rinse, repeat data science method that brought us to high-quality models. Let me walk you through this wash, rinse, repeat data science method. So we start by reading scientific article and defining the behavior in question. For example, we define what is a personal insult and which type of sentences belongs to this behavior, as we discussed in the previous slides. Our young team of analysts who specialize in social media collects all relevant examples. Imagine the time and effort it takes them to collect all these kind of sentences, all nuances of informal language. They need to understand each sentence and label it to the correct category, meaning to find out which behavior the sentence belongs to. They collect, annotate, analyze, and redefine the behavior again and again. When there is enough data, our science team collects this data, pre-process, and build a model. Then we do an error analysis. The scientists and the analysts sit together and view the results of the model. This helps us to redefine the behavior and make better models. These iterative loops of data and science, separately and together, help us to define the behavior better and better and provide more accurate results. Since we have been using this method, our models improved dramatically. We have been working on the personal insult model for about a year now. In the graphs you can see the improvement over time. As the training size grows in green and the agreement rate between the analysts grows in orange when the behavior is more and more defined, as a result we see increasing F1 scores. This improvement in F1 scores also reflects the model improvement over time. Now let's talk about our models. So what is our favorite data model? Over the past few years, neural networks have turned out to be powerful models, providing excellent results. We use a transformer, which is a new family of NLP neural networks. I recommend reading the article "Attention is all you need" to better understand the concept behind the transformers. When training a model, we need to choose which model to use, which transformer, and also tune many parameters as optimization technique, learning rate, etc. This is not a trivial task. To do so, we use Hugging Face library, which made it easy for us to experiment with many types of transformers and their parameters. To date, as you know, NLP models includes many Muppets as Elmo, Bert, Roberta, etc. With enough examples and the right model, we can initialize our embedding layer to random values and let the network turn them into good vectors. When we move to transformers, we managed dramatically to improve our model accuracy. But the question still was, how could we improve it further? We discovered that by translating our sentences, we could further improve our accuracy. Translating our sentences from English to other languages and then back to English improved our F1 scores in about 5%. Take a look on the example in the slide. They look so dumb. We translated it to French and then back to English, and we got they look so stupid. Translating all the training set from English to several languages and then back to English resulted
in increasing our training set, and we have gained diversity in the sentences. This resulted in more accuracy to our model. In addition to accuracy, there are more factors that need to be taken into consideration, like runtime and scale in production. BERT runtime was not practical in our case, so we had to speed it up. First, we reduced the sequence length, the input size. This reduced our runtime by about 30%. Then, we used smaller models, such as DistillBERT. This further reduced our runtime by 40%. There are more factors like the hardware that we are using. We use GPU or CPU, depends on the application. For real-time applications, we use CPU. For batch application, we use GPU. We got amazing results. Our personal insult model has practical runtime of 100 milliseconds, and look on the slide on its amazing R curve. And finally, to summarize, we at Light deliver high-quality detections with practical runtime using the wash, rinse, repeat data science method to build and improve our transformers models. Thank you for your attention. Thank you for inviting me. Please feel free to email me any questions or comments. Thank you.
Meet Dina. She's a data scientist. In her free time, she loves practice yoga. And meet Paula, her product manager. She has 3 cats and a dog. One day, Paula, the product manager, comes to Dina and tells her that a new feature is needed. We want to draw a white contour around each duck in the image. Dina, as a good data scientist, spent her next 2 weeks doing research. After 2 weeks of research, Dina comes back to Paula, her product manager, and asks for guidance. She found several relevant methods and she needs help to narrow it down. Paula is puzzled. She is not sure how she can help. This type of conversation happened to me several times during my work as a researcher. Both me and the product manager were frustrated. I'm Sivan Biam, and I'm a computer vision researcher and algorithm developer at Healthy.io. I hold a master's degree in computer science from the Weizmann Institute of Science and a bachelor's degree in computer science and neuroscience from Bar-Ilan University. In my free time, I love practice yoga and running. Today, I'm here to share with you my experience as a researcher in a product-oriented startup. Let me describe you. You have probably heard at least one lecture or read one blog about the relationship between product managers and developers. Today, I'm here to talk about the unspoken relationship between product managers and data scientists. Let me describe you the main pain point in this relationship by quoting Donald Rumsfeld, a former Secretary of Defense in the United States. There are known knowns. There are things we know we know. We also know there are known unknowns. That is to say, we know there are some things we don't know. But there are also unknown unknowns, the ones we don't know we don't know. And this is exactly the main pain point in this relationship. Most of our work as data scientists lies here in the area of the unknown unknowns. When we get a new feature to develop, we don't know if we will be able to get results and if those results will be relevant to the product. What makes it even more complicated is that the method we found wasn't originally applied on our domain. We don't know if the method we chose that was applied on images of cars will work on our images of ducks. This leads us to the unknown of the correct method. We don't know if we chose the correct method to start with. Only after a while, we might figure out that we chose the wrong method and we need to start again with a different one. A consequence of all this is the time estimation unknown. Because we don't know if we chose the correct method and if this method will work on our domain and if we will get results, we can't give time estimation. We don't know when we will finish this feature or even when we will have meaningful results. This all together makes the product manager work harder. It's hard for him to understand what is the current status of the feature and where we will be a few weeks from now. He can't plan the next steps. Now, let's start again the case study from before, and let's see how we can use it in order to make this relationship better. So again, Paula, the product manager, wants to add a new feature to the product. Dina, the data scientist, spends time doing research and comes back to Paula and asks for guidance. Paula is puzzled and she is not sure how she can help. Paula, the product manager, tells Dina that in order to help her, she needs to see some results and examples for each one of the methods. It's the only way she will be able to understand which one of the methods is the best for the product. But Dina, the data scientist, can't give her that. In order to give her results and examples for each one of the methods, she will need to research and implement each one of them. It might take her several months for each method. This frustrated conversation keeps going without any practical decision. Both Dina and Paula are frustrated and they are not sure how to continue from here. But we are here today to see how we can make this relationship better. So let's put it all behind us and let's try again. Let's see if we can change the frustrated faces into happy ones. So again, Paula, the product manager, wants to add a new feature to the product. We still want to draw white contours around each duck in the image. But this time, Paula elaborates more. She tells Dina, the data scientist, what the user experience will be, what inputs she will get from the user, what the goals and the requirements of this feature, and what is the expected timeline. Now, Dina, the data scientist, can focus her research only on methods that meet those requirements. After 2 weeks of research, Dina still needs guidance. She found several relevant methods and she needed help to narrow it down. But this time, she elaborates also. She tells Paula, her product manager, what those options are, what are the requirements, what type of data we will need, which resources we will need in order to implement them, and more. In addition to that, she also tells Paula what she thinks is the best method to start with. Because Dina is the data scientist, she's the one that's in charge on the technical aspects of this feature. So her thoughts and intuition regarding each one of the methods is very relevant. In contrast to before, now Paula has better understanding regarding the options. Paula likes Dina's recommendation. Together, they are now planning their next steps. After some time of research, Dina, the data scientist, understands that some objects are more challenging to detect and have higher chances to get inaccurate contour around them. As you can see here, some boxes around the ducks are inaccurate, which result in an inaccurate and partial contour around the ducks. Dina has an idea how to overcome it. Another input from the user, like marking a dot at each relevant object, will help her to improve her results. As you can see, using the dots, Dina is able to get accurate boxes around the ducks and accurate contours. This additional input not only helps Dina as data scientist, but also the user experience. Now, the user will get results based on his input and will not get results for non-relevant objects. Paula needs to check it and see if it can be integrated into the product and the current user experience. She thinks it can be useful, but she will get back to Dina. After a week, Paula gets back to Dina. She might tell her that this additional input is approved, but she might also tell her that we can't add this additional input and we need to continue without it. Either way, what's important here is that we talked about it. A week after, Paula comes to Dina just to check in with her and see how she's doing. She also asks her if there is anything she can do to help her. Dina, the data scientist, doesn't have any meaningful progress to share yet. It doesn't mean that she didn't do anything in this time period. It just means that data science takes time. But she tells Paula, her product manager, what she thinks about her current status and what are the next steps that she is planning to do. After a while, Dina is stuck. She is not sure if she can figure it out. She is not sure if she will get results and when. She is starting to think that maybe she chose the wrong direction. And here, Paula comes to help. Maybe she can't help with the technical aspects of this feature, but as the product manager, she sees the bigger picture of the product and can ask guided questions. She can ask Dina, the data scientist, where she thinks we should put our efforts on, how much effort it will take her in order to figure this method out, and how much time and effort she will need in order to go back, choose a new method, and start again. Dina answers these questions. It's not really important what the answers are. What's important here is that we have this open conversation regarding the current status of this feature. In contrast to the frustrated conversation from the beginning of this talk, now Paula understands better what are the options for this feature. She has all the information that she can get. By having all the relevant information, Paula can get an informed decision for this feature next steps. She might decide that we should continue with this current method and put all of our efforts on it. Maybe we should try a different direction, go back a few steps in order to move forward. And maybe we should leave it for now and come back to this feature later in the future. Maybe our product is not mature enough. Maybe we don't have enough data. And maybe we don't have enough technical understanding of the technical challenges. So what actually happened here? We did it better together. By having this open conversation and by sharing our thoughts, intuition, and progress at each step of the way, it helps both sides, product managers and data scientists, to do their job better and happier. So what do we learn? Let me share with you my tips for both data scientist and product manager. I will start with us, the data scientist. First, and I think the most important one, is understand your product. Your product manager will not always be able to help you, but understanding your product will. Just like Dina was able to suggest an additional input to the product that not only helps her as data scientist, but also the user experience. Explain your intuition. Help your product manager to understand your intuition. If he will understand you better, it will be easier for him to help you back. And share your progress. Don't wait until the end of your research to share your progress. Share your progress as frequently as you can in order to make your product manager work easier. And my tips for you, the product managers, is first, give focus. Explain in details what are the goals, what are the feature goals, requirements, and timelines. Give us, the data scientists, all the information that you have regarding this feature. Be patient. Data science takes time. Sometimes a lot of time. Sometimes we'll need to go back, choose a new method, and start again. And check in sometimes. Don't be a stranger. Don't leave us to work alone for several months. Your guidance and opinions are crucial. And if I will sum it up, I will say that we, as data scientists, should understand our product, explain our intuition, and share our progress. And you, the product manager, should give focus, be patient, and check in sometimes. And don't forget, we can do it better together. By having open conversation and sharing all of our information during this entire process, most of our works as data scientists and product manager will be easier and happier. I want to thank Shulamit Ferber for this great comic. You can follow her on Facebook and Instagram. And I want to thank you for listening. You can reach me at my LinkedIn and my mail. And feel free to visit my blog. Thank you and good night.
Hi everyone, my name is Tamar and I'm a senior algorithm engineer at Brizometer. Today I'm going to talk about how software and algorithm integrated teams help us to improve the health of billions worldwide. But first I want to start with a little bit of background. I did my bachelor and master degrees in environmental engineering, and during my studies I got caught on the subject of air pollution. I found it the most difficult and problematic environmental risk. Air pollution is a silent killer that leaves no one unaffected. According to the World Health Organization, the WHO, every year there are 7 million deaths because of air pollution. It also causes strokes, heart disease, lung cancer, COPD, and asthma. And there are many other known and diverse health effects. What got to me the most with air pollution was the understanding that you can't choose to stop breathing, you just have to do it. Wishing to improve the situation, I ended up working at the algorithm team of Brizometer. At Brizometer, we aim to help billions of people worldwide. We want to improve the health. We do that by providing environmental data such as fires locations and pollen allergens levels. We also provide real-time air quality levels at 100 countries worldwide. Our data is available on our app and on our website, and more importantly, on our customers and partners platforms. For example, Apple Weather app shows our data at many countries. You can check your iPhone later and search for New York and see what are the current air quality levels over there. Air pollution is dynamic and difficult to monitor and model. It varies both spatially and temporally. If you will look at the example, you will see the rapid changes of air quality levels. That's why we need a strong algorithm team that will be able to research and develop the best algorithms so we could provide our users with the most accurate data. As an algorithm engineer at Brizometer, I work on the research and development of many types of environmental algorithms. For example, our data is being calculated in real time on a grid of 500 on 500 meter square resolution. That's amazing. And that's 459 million grid points, which ends up as 1.8 terabyte each hour. Our need to solve environmental problems such as how to accurately model the air quality levels on these grid points, combined with the need to do this complex calculation on such a scale, that has pushed us to develop a beneficial relationship between the algorithm and software engineers. Back in 2016, when I joined Brizometer, the algorithm team was a separate team within the R&D department. Over time, the algorithmic challenges got bigger, and so was the required scale and technology that was needed for the solutions. Almost 2 years ago, the structure of the R&D was adjusted to fit the challenges. And now, the algorithm teams are multidisciplinary and include both algorithm and software engineers. This new team composition allowed us to evolve and raise our game. As in many algorithm teams, the responsibilities of algorithm engineers are to research the scientific aspect and how to define the logic behind the algorithm. We also research the possible methodologies and which optimal solution is best for us and for our needs. And we do the development and implementation of the algorithm to our systems. Yet, we are not software engineers. So if we want to understand what is the responsibilities of the software engineers within the algorithm, the integrated algorithm team, so it's first to build and maintain the infrastructures that are responsible for running the algorithms. In our case, we run everything on the cloud, Google Cloud Platform. Our system uses microservices architecture. Also, as part of their responsibility, they are doing optimization to the algorithms and deploy them at large scale. Most of our algorithms are Dockerized and being run on a large Kubernetes clusters with thousands of nodes. They also build and maintain internal tools to make our life a bit easier based on the algorithmic needs. And they have an ongoing dev support for algorithm engineers. They take part in the process of solving the problems and help us to improve the code quality. So what are the advantages of the integrated teams? So first we need to understand the way we work in Brisometa algo teams. It's by cooperating with our software engineers from the beginning of each project's research phase. The software engineers takes part in the brainstorm we do and in the decision makings. They also help us with the design and review our code. The company gain is that our team became unified squad with common goal. Our communication is better and we are much more sync than before. Also, during the stages of the research and the development, the team as a whole is more aligned with the product under the development. And also, we achieved shorter cycle time from concept to actual product. All this leads to a better performance of the team. The personal gain of the algorithm engineers from these integrated teams is that we learn a lot from the software engineers. For example, how to use cutting-edge technologies such as Docker and GCP, and this improves our solutions and our abilities. The personal gain of the software engineers is that the opening of a new field of interest and expertise and the learning of new abilities such as statistics and packages like pandas and scikit-learn. In order to demonstrate the advantages of the integrated teams, I want to share with you an example for a project that we worked on together with software engineers. First, I'll explain the motivation for the project. As you know, car emits air pollutants. In the traffic project, we worked on adding the effect of the traffic jams on the air quality levels in real time and on the street level resolution. What we wanted is to provide the user with the most accurate information and with the best resolution we can have. In order to calculate the pollution emission of each traffic jam to its local surroundings, the best solution was to use some complex machine learning models that they take into account the traffic parameters and geographical location. When we first developed this product, the software engineer joined us only when the research phase was close to completion. However, after a while, when we got to do an improvement project on this algorithm, we had a gifted software engineer alongside us who was part of the project since its very initial stages. And that was a great experience. We were able to accomplish our tasks faster, and a lot of the heavy lifting of big data extraction and analysis was done by her. And she also pushed us to higher coding standards. And that was even before she was actually part of the algorithm team. Since then, and after integrating the software engineer into the algo teams, we improved our work processes and achieved such a high level of understanding and cooperation between us that there are many things that just goes without saying. In Brisometa, we strongly believe in the approach of integrated teams. We're such a believers that we are currently in the process of scaling the teams, and we recruit more and more software and algorithm engineers. So if you ask me, will this model work in other companies? The answer is yes. I believe that this model of multidisciplinary teams is relevant and beneficial wherever there are algorithmic challenges with scientific background. For example, in software companies that is based on sciences such as biomedicine, agriculture, physics, biology, and other disciplines, this team model will work good. I also think that data science teams should consider this team composition. I believe that having software engineers as part of the data science teams can improve their work and the time spent to get the projects done. So I just want to thank you for listening to this talk and invite you to contact me with any follow-up questions. Bye-bye.
Wow, what another fabulous day covering data science, machine learning, and NLP. So many beautiful sessions, so many inspiring women once again. Thanks again to all of our amazing sponsors. We truly couldn't have done this without you. All of these companies are companies that actively support diversity as part of their agenda. Thank you for being part of the change and helping us to make sure these incredible and important voices are heard. Thanks to all of our speakers, our keynote speakers, event handler for producing the event, and to all of our course mentors and instructors. Be sure to follow us on social media, invite our speakers to speak at your next event, register as a speaker on our platform yourself, or register to our next round of the Speakers Academy. My name is Moran Weber, and on behalf of me and Women on Stage, we really hope you enjoyed yourself, and we're looking forward to seeing you tomorrow on our third and last day.